This is Dan Abbott. I'm making this short video to clarify how easily you can create or determine a class of fit on a shaft basis if you can start with a hole basis. And that's the easiest way to do this. People are making this harder than it is. No matter what, if you have a specific class of fit, that means you have a relationship between a shaft and a hole that is either a clearance, an interference, or overlaps. However you start, you have to have the same relationship between the shaft and the hole in order for it to be the same class of fit. Think of it as an equation. You can have an equation in math and say one side of the equation equals the other. Change either side, and as long as you change the other side in exactly the same way, it's still an equation. So the fits are going to be equal to each other as long as anything you do to every one of those numbers is the same. So we're looking for four numbers. And a reminder, I'm over here in 312 thou. That's what the letter C is. Shaft basis, and the category of fit was an LC6. That's what it was called out as. So I've got the LC6 section from the Machinery's Handbook. We're looking right down here in this row. These two numbers are going to be useful to us in terms of checking our work. What I'm looking at right now are those four numbers. It tells me that on a hole basis, the size of the hole at its maximum material condition is the nominal size, adding nothing, subtracting nothing. So if I look at the hole, the nominal size of the hole and the max material condition size of the hole are the same. So MMC for the hole is going to be 0.312, 312 thou. Right now, what does that mean? That means we're going to have another size for the hole, and the other size for the hole is going to be above, it's going to be right here, and that's going to be the least material condition. And that happens when the hole gets bigger. So the least material condition size for the hole is going to be 312 plus 1.4 thousandths of an inch, or 0.3134. I must put a 0 right there just to clarify that. So all I've done here is taken 1.4 thou and added it to this. So that gives me my hole sizes. Now I go over here to the other side, and now we're looking at the shaft sizes. Now here I'm going to go max material condition size of the shaft is going to be the nominal size minus a half a thou. So we're going to take the nominal size, whatever we start with. And in this case, the nominal size is 312. We're going to subtract a half of a thousandth of an inch from 312. So the MMC for the shaft is going to be 0.3115. That's 0.3120 minus 0.0005. That's going to give us this number right there, and that is the MMC for the shaft. Now we come down here, the least material condition size for the shaft is going to be the nominal size minus 1.4. Happens to be the same as this number, but that's kind of a coincidence. These others aren't the same. So we're going to subtract 1.4 from 3.12. That's going to give us 0.3106. So that's the least material condition size of the shaft. Now, no matter what, that's the same relationship we need to have for all of them. So if we look at max material condition size of the hole, max material condition size of the shaft, the difference between those two is 0.5 of a thousandth of an inch, which is represented right here as the minimum clearance. Look at the least material condition size of the hole and the least material condition size of the shaft, and the difference between those two is 2.8, which is the maximum clearance. Those numbers have to apply no matter what. So what are we going to do to change this to shaft basis? To change this to shaft basis, I'm just going to copy all these down. To change this to shaft basis, we need to make the shaft max material condition the nominal size. That's the only change we need to make to the shaft max material condition. We need to say that should be 0.3120. Now, what did I have to do to change that number into that number. I had to add 5/10 of a thou. Well, again, it's like an equation. If I add 5/10 of a thou to this number to get this one, I have to do exactly the same to the other three numbers. So now, what's 5/10 added to 0.3106? That's going to be 0.3111. What happens if I add 5/10 to this number? That's going to change it from 0.312 to 0.3125. And what's going to happen if I add 5/10 to this number? It's going to change that from 0.3134 to 0.3139. Now, the relationship among all those numbers is exactly the same. What's the difference between the maximum material condition size of the shaft and the hole? 5/10. 5/10 is right there. What's the difference between the least material condition size of the shaft and the least material condition size of the hole? 2.8. 2.8 thousandths of an inch. Same numbers we have right here. So again, it's like an equation. You can do anything you want to those numbers as long as you do the same thing to all four, and you'll have the same relationship between the shaft and the hole. Now we come over here to D, 312. So we're still dealing with 312 thou. So what I've done here, the one that refers to the category or to the range that includes 0.312 or 312 thou. So I'm going to do the same thing. I'm going to start by calculating on a hole basis, and it's easy. We just start by using max material condition size of the hole. It's going to be the nominal size. So we'll do the same thing we did over here. I'll say MMC for the hole is going to be 0.3120, 312 thou. Least material condition size for the hole is going to be 312 plus 1.4, or 0.3134 thousandths of an inch. That's on a hole basis now. And I'm just doing that by adding those numbers in. Now we come over here and we have MMC for the shaft. MMC for the shaft is going to be nominal size minus 1.6. We subtract 1.6 from this and we end up with 0.3104. 0.3104 is the difference between that number and 1.6. That's the max material condition size of the shaft. LMC of the shaft, the least material condition size, we have to subtract from the nominal size 2.5. We subtract 2.5 from this number right here, and we get 0.3095. So we're going to write 0.3095 over here. Now that's on a hole basis, and most of you had no trouble with that because you're taking these numbers directly out of this table. Now if we take a look at the relationship, the difference between that number and that number is 1.6. So the difference here is 1.6, that's the minimum clearance. The difference between these two numbers is 3.9, and again that's 3.9 thousandths of an inch. So we have that to confirm that this is done correctly. So now all we have to do to get the copy that. All we have to do to get this same class of fit for that size on a shaft basis instead of a hole basis is shift all the numbers in the same direction, the same amount, just like you would with an equation where you can add 5 to the left-hand side, and that means you just add 5 to the right. So in order to go from hole basic size to shaft basic size, I just need to turn the max material condition size of the shaft into the nominal size, the number I start with. Here, it was a hole. Well, I need that to be that number. So what do I have to do to get that number to be this number? I have to add 1.0016 to that. When I do that, I get 0.312, the nominal size of the hole in the shaft, but it takes adding 1.6 thou in order to do that. Well, if I'm going to do that here, I have to do it to the other three, or I don't have the same relationship. So what do I do if I add it down here? If I add it down here, I get 0.3111. That's what I get when I add 1.6 to this number right there. All right, that's fine, but I have to do the same thing over here. I have to add 1.6 over here. If I add 1.6 over here, I get 31.36. Now that's the max material condition size of the hole. And if I'm going to do that, I then have to do the same thing down here. If I do the same thing down here, then I'm going to add 1.6 here, so I am going to get 0.3150. So now we take a look again to see what the relationship is. What's the difference between the max material condition size of the shaft and the max material condition size of the hole? 1.6, which is that number right there. Same as it was in hole bases. What's the difference between these two numbers right here? Well, you subtract that number from this one, you get 3.9. So again, simple. You have to have the same relationship, and you can confirm whenever you're doing a class of fit calculation by looking over here to see what it is.